Hello everyone, this video will discuss about integration questions. So for this question we need to use substitution. So let u is equal to tangent x, differentiate it, will get secant square x. Let dx as a subject, so ds is equal to du over secant square x, and then integrate the function in terms of u, and then cancel out the secant square x, so integrate it as usual. And then substitute tangent x back into u, and then evaluate it, and you will get 2 over 3. We also need to use substitution for this question. So let u is equal to x cubed plus 9, du is equal to 3x squared, make the x as a subject, and then substitute 2, and then cancel out the x squared. Just integrate this, you will get this, and then evaluate it, and it will become this, and then simplify, and you will get 2 times square root of 10 minus 4 times square root of 2 over 3. For this question, we can rewrite it as this to make it easier for you, and then just integrate it like the usual. Notice that a is a constant, so integration of square root of a we will get square root of a times with x, and just integrate square root of x. You will get like this, and then substitute the answer, evaluate it, and you will get this. And if you simplify it, you will get the final answer, which is this, negative 5a times with square root of a over 3.
Okay, so let's move on to question 21D. This question asks us to integrate x plus 2 sine square x. So please bear in mind that 2 over sine square x is actually equal to 2 cosec square x. So when we integrate x, we will get x squared over 2, and when we integrate cosec square x, we will get negative cot x, and we just need to substitute the integrals in x. When we substitute, we will get this kind of equation, but this equation will lead to undefined value because tan pi over 2 means tan 90. Tan 90 is undefined. Okay, so in this question, it requires us to integrate cos 3x. Okay, cos cube x, we can factorize cos x and multiply by cos square x. Cos square x will be like 1 minus sin square x. This is the identity of cos square x. Then we'll use substitution method where we let u as sin x, and then we will get this kind of equation, and then we integrate in terms of u, and then we will get this kind of equation. We substitute u as sin x, and then we substitute the value of the integral, which is pi over 2, in x, and the answer will be 2 over 3. Okay, so this is the equation for 32b, and then it will get this kind of equation. I separate it with part 1 and part 2. Okay, so when I settle down for part 1, I will get this kind of equation, and I use substitution method to settle down it. And after I substitute the value of integral, it will be like this. So the answer for part 1 is 0.04. So for part 2, I use reduction formula to integrate this. And then after that, I will get this kind of equation. And then I substitute pi over 6 in x, and the answer I get is 40.8. So lastly, I substitute part 1 and part 2, and the answer is negative 14.76.
Question 32c, we need to integrate 1 over 1 plus cos theta square to the respective of theta. First of all, we need to inverse the equation, and we will get 1 plus cos theta to the power of negative 2. And then we just use the basic law. We add up negative 2 by 1, and we will get negative 1. And we put the negative 1 under the equation. And we also differentiate the equation, the inside of the equation, and we will get negative sin theta. And we also put it under the equation. And then we will get 1 over sin theta times 1 plus cos theta. To get the value, we just insert the value of pi over 2 and 0 into the equation, and we will get this equation. So for these terms, we will get 1, and for this term, we will get undefined, because sin 0 is equals to undefined. So for this question, the answer is undefined. 22D, we need to integrate sin cube x over cos x dx. For this question, we use the substitution method. Okay, first of all, we need to split the sin cube x into sin square x and sin x. And then we use the basic identity, and we substitute the sin square x with 1 minus cos square x. and then we'll get this equation. And then we let u equals to cos x, and we will get dx equal 1 over negative sin x du. We substitute u and dx into this equation, and we will get this equation 1 minus u square times sin x over u times 1 over negative sin x du. And then we will just simplify this equation, and we will get, so integrate u minus 1 over u du. And after we integrate, we will get u square over 2 minus 1 over u. And then we substitute back the u over cos x, and we will get cos square x over 2 minus ln cos x. And then when we substitute the value of pi over 2 and 0, and you can see here when we substitute pi over 2, we get ln cos pi over 2 is equal to ln cos 0, which is undefined. And then the answer for this question is also undefined. Question 23a. Integrate hyperbolic sine 3x plus 2 to the respective of x. For this question, we just use the basic law. First, we need to integrate hyperbolic sine. When we integrate hyperbolic sine, we get hyperbolic cos. And we write back the 3x plus 2 at this place. And then we differentiate the inside of the trigonometry, 3x plus 2, and then we will get 3. And we put the value, the 3 under the equation. And the answer will be hyperbolic cos 3x plus 2 over 3.
So for question 23b, we need to integrate hyperbolic tan x over 2 dx. So we change hyperbolic tan into hyperbolic sin over hyperbolic cos. So after that, we use substitution method to integrate this. Let u equals to hyperbolic cos x over 2. Then differentiate it. Then put it into the equation. Then we just integrate 1 over u equals to ln u. So 1 over 2 ln u plus c equals to 1 over 2 ln hyperbolic cos x over 2 plus c. So next, for question 23c, we need to integrate hyperbolic cos sec x over sec x dx. So we use substitution method by letting u equals to sec x and differentiate it, and we get 1 over sec x. 2 du equals to 1 over sec x dx. So we just substitute into the equation, and we differentiate hyperbolic cos equals to hyperbolic sin. So answer is 2 hyperbolic sin u plus c. Then we just put u back from there equals to this. For question 23d, we need to integrate x hyperbolic sin 7x square. So we are going to use tabular method. Differentiate x into 1, 1 into 0, integrate hyperbolic sin 7x square equals to this, and integrate again equals to this. So we just multiply like this, and then we get the answer.
Okay, now for this question, we need to integrate cos hyperbolic x to the power of 6 multiplied by sin hyperbolic x to the respect of x. I'm going to use the substitution method. First, we need to let u or any other variable or any other constant equals to cos hyperbolic x. And then we need to find the derivative, which is sin hyperbolic x. And after that, I want to find the dx in terms of du. So you will get dx equals to du over sin hyperbolic x. And you need to substitute u and du into the first equation, which is this one. And you will get u to the power of 6 instead of cos hyperbolic x to the power of 6. And as you can see, we can cancel sin hyperbolic x, and we will get this. And after that, just integrate it normally, and you will get this answer. How do I get the cos? From the first one. Okay, now for the next question, we need to integrate tan hyperbolic x, square root tan hyperbolic x multiplied by secant hyperbolic x square to the respect of x. Same as the previous one. Let u equals to tan hyperbolic x, and then find the derivative, which is secant hyperbolic x square, and find the dx in terms of du. And after that, substitute u and du into the equation, and as you can see, we can cancel out secant hyperbolic x square, and we will get this u to the power of 1 over 2, which is square root. Integrate it normally, and we will get this answer based from the let u equals to 10 hyperbolic x. Okay, now for this question, we need to integrate dx over x squared multiplied by x plus 1. This equation is actually the same as this one. So in this question, we need to use the partial fraction method. So we need to put it in the form like this. And after that, I want to get rid of the denominator. So I will get it like this. And this is a simplified version, so you can see it more clearly. And you will get b equals to 1, a plus c equals to 0, and a plus b equals to 0. And a will be equals to -1, b is equal to 1, and c is also equal to 1. So substitute the value back into the equation and you will get this. And after that, just integrate it normally. I integrate it one by one so that it will be much more easier and clear, and this will be your final answer.
Point B, first step we need to factorize it. We got tangent x squared, tangent x squared, and then we need to substitute one of them with the second x squared minus 1 based on the trigonometric identities, and then we multiply it, and then we got this equation, and then we need to integrate for each part. So for this part, we need to use substitution method, let u equal to tangent x, and then when we differentiate it, we got second x squared, and then we integrate in the term of u, and then finally we replace with u with tangent x, we got tangent x to the power of 3 over 3. And then for this part, we just substitute with the same formula, second x squared minus 1, then we integrate normally, we got tangent x minus x, then we combine it, and then finally we got the answer of tangent x to the power of 3 over 3 minus tangent x plus c. The 4.c, first thing we need to multiply x, and then we got this equation over here, x squared minus 4x over x minus 2 bracket of to the power of half, and then we need to use the substitution method like t equal to x minus 2, and then we need to express x in the term of t, then we replace x which is t plus 2, and then finally we got the equation of t squared minus 4 over t half, and then we need to integrate it, and then finally we got the equation of t power half bracket 2 over 5 t squared minus 8, then we need to replace t with x minus 2, and we got this equation. Because this has a limit, we need to insert the value of 6 and 3, so if we put the value of 6, we got this value, and then we put the value of 3, we got this value. Lastly, when we solve it, we got 32 over 5. 4.d, integrate x squared plus 2 plus x to the power of -3 with the limit of 2 and 1. After we integrate normally, we got this equation, then we replace x with 2, we got this 157 over 24, and then we replace with x with 1, we got 11 over 6, then we solve the equation, we got 113 over 24.